So I'm wearing my eclipse t-shirt because yesterday we had a total solar eclipse. Well, not Los Angeles, but Oregon, in Salem, Oregon, it was in the path of totality. And so for this past weekend, which was actually my birthday weekend and is my wife's birthday weekend, we drove up to Oregon and spent the weekend in Salem, and we sat outside and watched the total solar eclipse. And I have to say, it was absolutely amazing. Did any of you guys look at the sun yesterday with the special glasses? Okay. Looking at the sun where it's a partial eclipse is nothing like the event of totality. Okay, I mean, it's just like, you know, you look at the sun and you see this orange circle with like a bite taken out of it, and you're like, oh, that's cool. But I have to tell you, when you the event of totality is very it's unlike anything else, because as you see the moon covering up the sun, you can feel the air getting colder, and just the shift in the temperature and the amount of light coming in. There's this kind of this surreal experience of, you feel like something magnificent and monumental is happening, and you know, and I could feel my heart racing as the moon was covering up the sun, and then at that moment of totality, which only lasts, you know, 2 minutes, the sky is this brilliant blue, deep blue color, and the corona, which I mean, you probably see photos of it, but it's much more impressive in real life, because there's, like, in the picture it's very flat, but when it's in the sky it feels, I don't know, it's like seeing a 3D image for the first time or something. I don't know, it's very so anyway, I recommend that at least once in your lifetime to make a trip to somewhere along the path of totality and experience a total solar eclipse. And so I think there's going to be one in 7 years in the United States, going from Texas up through Ohio and Maine and things like that. And I think, you know, for those of you in the U.S., in 7 years' time, I'm definitely going to make another trip, because I want to see this thing again. So anyway, it was excellent. Okay, now I will tell you about importing data, scraping data, and text processing. So I guess we'll get started there. All right. This is much less impressive. This feels trivial in the grand scheme of the universe, and well, important for, I don't know. All right, whatever. Okay. I love this stuff, by the way. That actually, this text processing and regular expressions, it's one of my favorite topics. Everything pales in comparison to the universe, but as far as doing stuff in R and whatnot, this is about as cool as it gets. No, I don't know if that's true. It's really cool though. Okay, let's talk about importing data. We have we can input stuff from a file. Okay, we've got scan and read line and read.table and read.csv. I imagine you guys have used read.csv in Stats 20, and perhaps in Stats 20, did you guys use reader and use read_CSV? Okay, so probably some combination of read.csv or library reader with read_CSV. Scan is pretty much just reading in a file, and you know, read.csv kind of does a little bit of stuff around it, so that it's not just reading in raw text, but you know, putting it into a data frame that can then be used. But if you needed to just read in raw text, you can use scan or read_line. And of course, look at the help files for those things. If you're dealing with something where you want the text in its raw form rather than trying to be turned into a data frame. Okay, we have, you're probably familiar with several of these packages. Reader is one created by Hadley Wickham with some that's good for reading in CSV and text files. Then we have Read Excel for Microsoft Excel files. Haven, which is used for importing data from other statistical packages such as SPSS, Stata, and SAS. And then you have data.table and FRead. FRead, I think, stands for fast reading and is very powerful for very large data sets. So if you're, for DataFest, and you get like this 4 GB file or something like that, FRead is probably the way to go, okay, for something very large. I mean, you can just use FRead for almost everything, then all of these things. And there's a good webinar here on getting your data into R. It's a 45-minute video, and it's well worth your time if you have questions about importing data. But I imagine this is something that many of you guys are already somewhat halfway familiar with, and you guys know how to read help files. So we won't dwell too much on this thing. Okay. If you need to import data off the internet, you can use Package Downloader. Okay. Now, why would we want to do this rather than just going to the web page in my browser, clicking the link and clicking Save As or something? Well, that's perfectly fine. But if you use something like Package Downloader and put in the downloading instructions into your R script, you can then give the script to someone else, and then they will run it. And by them running the script, it will download the file and load it up all in one go. Okay. Otherwise, you'd have to have separate instructions, right? You'd have your script, but then you have separate instructions that say, before you run the script, you go to this web page and click this link and save it in this, your home directory. Basically, Package Downloader allows you to automate those types of things, which, as far as reproducing what you've done and sharing what you've done with other people, the fewer outside instructions you have to give, probably the better. So library downloader will do this, and there is already a function called download.file, which works if you have non-secure links. But now there's kind of a shift that everything's going to HTTPS, and library downloader allows for handling that stuff without having to, I don't know, do all sorts of other stuff. Although, some web pages just don't play nicely at all with automated stuff. They code up their site to avoid robots from downloading their links. And so if that's the case, you might still have to send a separate message that says, go to this web page and download the link, because some web pages don't like it when they sense that it's a robot coming in to download their files. So anyway, Package Downloader. So I'm just kind of listing off packages that I think are good. So pretty much all you have to do is type in install.packages, and then when you say, oh, I kind of want to do this, just look up the help for that thing. So library downloader using the download thing. Okay. Package Lubridate. This is, I guess, a play on words here. And it makes handling date and time information in R much less painful, okay? So without package lubridate, it is a huge pain in the butt to handle dates and time things, okay? So let me just kind of show you the kinds of stuff that you might have to do with without lubridate, okay? So let's say somebody has this date here, 6th of August 2005. I mean, our brains are pretty good and we can look at something and we go, oh, we know exactly what these dates are. Although when something's in this format, it's a little bit ambiguous because, well, if it's 12/15, you know, but if it's like 12/2, you know, it's a little ambiguous, right? Are we in the United States or are we in Europe? Or, you know, the rest of the world other than the United States. But when you have something like this, without lubridate, you have to very, very specifically say exactly the form that the date is in. And so here we have %d, little d, to say that this is the day, capital B for the month, and then Y, capital Y for the year, and then it will understand that this is August 6th, 2005, and it will print this as .date, okay? But if any of these things are off, let me kind of demonstrate here. So if we so here is the text string 6 Aug 2005, and we want to turn this into a date, okay? So I can do this, and it's going to take the text string and convert this. However, if one of these things is even the slightest bit off, I have a space here. Oh, it works. Let's see. Maybe if you put a dash there, it fails. And let me see if I put in a lowercase b, that works. Okay. But a lowercase y causes it to import the wrong date because it sees the 20 and it thinks we're talking about the year 2020. Okay. And so it's very sensitive to let's see. It's very sensitive to the formats that are being used. Okay, whereas and so all of these things. So here's date 2 and date 3. To do date 3, we have to do this. If I change any of these things, I think to the wrong thing, it fails. So if you use a capital D or a capital M, these things will fail. And so everything kind of with lubridate, without lubridate, you have to make sure that all of the dates written in the thing are kind of of the same form and everything like that. With the lubridate package, you can just say turn it into a date. Okay, let me just demonstrate here. So this is with lubridate. It masks the old date function, and so here we've got the same texts, but notice all I have to do here is just say the first one is in day, month, year, and it recognizes, oh, there's the date there. There's month, day, year, and month, day, year here. Okay, and it handles both of these things. Whereas if prior, without lubridate, if you had people entering their birthdays and they came in slightly different forms, you would have to have a different format for every single type of date that you see listed, right? If you have a text entry, something, and people are inputting their dates or something into the field, you would need to have something to kind of clean everything up here. Whereas lubridate, it's just much more easy, and now we have nice little date functions here. Okay, and of course, with these things, you can start taking differences between these, and so the difference between January 15, 1999 and December 15, 2001 is, minus 1,065 days or something like that, right? So how many days until, I don't know, whatever, we can do this, okay? So that's package lubricate. Highly recommended for anytime you're dealing with date and time functions. Just, load that up there. Okay. Are there any questions on kind of this importing and handling of information here? You guys have seen a lot of this before? Maybe? If I get you guys to start using Lubridate to make your lives easier, then you've gotten the a good thing here. Okay, let's take a look at Arvest. Okay, have you guys seen Arvest before? Some of you are nodding your heads. Some of you are shaking your heads. Okay, well, Arvest, another play on words here. I guess it's like harvest, but with R, and it's for scraping information off of basically web pages. Okay, HTML things, and we are going to use Selector Gadget in tandem with Arvest in order to kind of make it work, okay? So Selector Gadget is this tool that allows you to select CSS tags, okay? And so here's kind of the little video on using Selector Gadget. Let's see, can I do this? So basically what you're going to want to do is you're going to install the Selector Gadget bookmark. I don't know. And then when you click that thing, here, you know what? I'll rather than playing the video, I will demonstrate this here. Okay. So go to selectorgadget.com, and then open up your bookmarks toolbar. So if you're on Chrome, I think you hit Control-Shift-B, okay, and it kind of pulls up your bookmarks toolbar. And what you're going to do is you're going to drag this link. You're going to click and drag it to the toolbar, okay. And basically, it's just this little bit of JavaScript code embedded in this thing, and it creates the kind of Selector Gadget link on your toolbar, okay. And then this allows you then to go to some web page, okay, and select items in the web page based on its CSS tag, okay. So, for example, I can go to here's UCLA's schedule of classes, and let's see. We'll get a listing of all of the stats classes in fall 2017. Actually, I hope this works. Okay, so here, I've loaded up our registrar's office webpage here, and I have the Selector Gadget link in my toolbar. So I'm going to click this, and here, let me minimize this video thing. And you'll notice this little, the web page is now acting all crazy, and this little thing across the bottom appears, okay? So again, when you first have to go to the Selector Gadget web page, you click and drag this link to your toolbar. You go to the web page that you're interested in, and then on that page you click the Selector Gadget link. This little box down here appears, and then you say, okay, I want to get all the links on this page, or all the things on this page that look like this, okay? And I click this here, and this is highlighted in green. Maybe I also want to get something that has this, okay? So I clicked that thing, and so this is highlighted in green, this is highlighted in green, and it tells you, okay, if I select everything with an A tag, everything that has a yellow thing is going to be imported. Now, I don't want these things imported, so I'm going to click this, okay? And so, you know, green means I definitely want that thing, okay? I definitely want this thing, and I don't want this thing. So I clicked this, and by clicking that, it has said, okay, we're going to select in the source code things that have .head A. So this is kind of like header level links. And we can see everything that's highlighted in yellow, and this is going to be kind of a list. It's just a list of all of the names of the course numbers and their names here, okay? And so through this, I have, and it tells you, I see 25 things that we're going to select, okay? So now I'm going to copy this selection setting. So this will help me select all of the tags that have that particular thing. Let's say you wanted something else. Let's say you didn't want that, but rather you wanted the names of the instructors. Okay, we can try to do that. So I would go to Selector Gadget. It loads up, and you know, you just kind of hover over the piece of text that you want. I want this, the name of the instructor. Now this has highlighted way too much stuff, right? So I say, okay, well, I don't want this thing. Oh, this could be a problem. Let's see. Can we get this also? But we don't want this. Okay, so I've selected this, and I said I don't want this, and it appears, oh, and we also don't want this thing. Okay, so when I've selected this, it seems it has selected everything here. It's going to get cha, m, ta, 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 sang, m, so on and so forth. This looks good. I think we do want this, and I clicked that, and so now it seems it has selected the correct tags that I want. Okay? Does that look fair? Okay? And so here it says the tags that we're going to use here is class not checked, instructor column, and P. Those are kind of the combination of tags that we're going to use to just extract all of these things that are in green and yellow. Okay. Maybe I can even get rid of TA by clicking this. Sometimes you, oh, look at that. Now it's just getting the top level instructors, but it looks rather complex. Oh, maybe. Okay. So sometimes, you know, you click too many things and it can't find a good rule here. So we might have to import just the TA tags as well. Okay. Okay. So this looks to be pretty good. Okay. Okay. So so that's Selector Gadget, and that tells kind of the set of tags within the XML or HTML code that we're going to use to select the things, or I guess even CSS tags there. Okay. Does that make sense? The use of the Selector Gadget tool there. Okay, and again, you're going to go to Selector Gadget, and you're going to just click and drag this to your bookmarks toolbar. Okay. Oh, there's also a vignette here on Selector Gadget. You're going to have to do install.packages rvest and load up rvest first. Let's do that. Library rvest, and then there is a vignette on Selector Gadget written by Hadley Wickham himself, and okay, I don't know how to make this bigger, but you can read it and it will show you how the thing works here. Okay. Yes, question.
So after you copy whatever the tags are,
yes.
Where do you put it in?
Now where do we go? Okay, yes. That is that's the next part. Okay. So if you download the code, I have posted up some code on CCLE that says rvest demo, and it will kind of show you how we're going to do this. Okay. So So I have loaded up rvest, stringer, and data table, these libraries. Let me clear my environment here. Okay. And so let me demonstrate what we will do. There is a function called HTML nodes or HTML node that we will use, and that's where we indicate the tags that we're going to use there. Okay, so here for this demo, we're going to the IMDb webpage for the Lego movie. Have you guys seen the Lego Batman movie? Well, if you like Batman and you like Lego, it's a great movie. Okay, if you like neither of those things, then perhaps not. Yeah, okay, well, all right. Apparently you can get the Mummy also. All right, so here's the Lego movie. And what we want to do is, I forget, in this code we want the cast, okay? Or maybe, okay, I guess we can start off with the movie rating, okay? So to get started, here's the Lego movie, and we're going to try to, we just want to extract this number here, 7.8. So I go to Selector Gadget, and I click that thing, 7.8. I don't want all of this other stuff, so I'm going to just click over here and say I don't want that. I also don't want this thing. And is there anything else that's highlighted? No. Okay. And this is perfect. It just says one thing is being selected, and if we use strong span, that, whoops, I didn't want that, then I will select it. Okay. To do this, we're going to use rvest, and we run the command read_html. Read_html basically goes to a web page and reads it in to R as some kind of thing. And here's, here are a few options. You can specify the encoding. I think it defaults to UTF-8, which is generally what we want, although occasionally that may cause problems. Okay, so I do this. I bring in Lego Movie. You of course need to be connected to the internet for this to work. And here it says Lego Movie is a list of 2, and we can ask what is the structure of this thing I just created using read.html. Okay, and it just says you've got 2 things: the node and the doc, and let's we can hit Lego _movie $node, and well, I guess it just says this pointer this. Okay, maybe this is as helpful as we want. But we have so read.html just creates this object, the Lego Movie thing. Okay, and it's of class XML document, right? If we say class, okay, it's an XML document with things at XML node. So what I'm going to do is I'm going to take the object Lego Movie and use the command HTML nodes. Okay, and here I'm using the pipe notation here. So I'm going to say Lego Movie. We're going to pipe that object Lego Movie into the command HTML node. Okay, node will pull out 1, and nodes will pull out multiple. Here, as far as the rating goes, the one tag that I wanted was strong span. Okay, and this is the tag associated. If you remember Selector Gadget, this is the tag associated with just the rating value, 7.8 strong span. There's only one thing that's getting selected, and that is that thing. So if I pipe Lego Movie into strong span and I hit enter, here we can see here's the node that's being pulled out here. Okay. There are a few things that we can draw. What we want to draw is the text itself. So we're going to take that node and we're going to pipe it into, we're going to say we want to draw HTML text. Okay, and when we do that, it pulls out the text 7.8. That's the text that was within the HTML or XML tag. Okay? Are you guys familiar with basic web page encoding to begin with? A little bit? Maybe? Okay. So if you ever go to a web page and you right click and you click view page source, it's all of this garbage, right? And what we want to look for is 7.8. This is kind of the thing here, okay? And so we can see right here, this is, can I make this bigger? All right, so oh dear, okay. Where did it go? Okay, so here we are. Probably right here. Okay, so here we've got strong and span, and that's kind of where it's getting the tags strong and span. You can see this word strong, and it says title 7.8 span, and then here it says 7.8, and we're this part is regular old text that's between these XML tags here. Okay, this when you have the kind of the greater than or less than greater than sign, kind of this entire thing is called a tag, and or a node, and it the contents within those things, that is 7.8. That's the HTML text that we want. We can also pull out other things. We can pull out things like this thing that says 7.8 based on 272,440 user ratings. Let me just see, HTML underscore attribute, I believe, is what we want to pull out. So if I say, take the previous thing, and instead of saying I want the HTML text, I can say I want the HTML attribute, and the name of the attribute that I want is title. Okay, no, maybe that was not correct. Let's see. Oh, okay. I'm sorry. It's not going to work because I just want the strong tag. So the strong tag has the title, but the span does not, right? So Lego Movie, HTML strong, HTML attribute, title. Let's see if this is able to pull it. Okay, so here we are looking at just the tag that has strong, and we're saying I want to know what is the contents of the attribute title here, and it has extracted this piece of things, 7.8 based on 272,440 user ratings from the HTML source code, right? And so basically your web browser, when you go to a web page, is looking at all of this stuff, and then based on its understanding of what all of this code means, renders it into something that we can read and appreciate. Whereas, obviously nobody wants to have to look at this. Back in the old day, web pages were much less elaborate, right? Do they still have the Space Jam website? I think that's like one of the oldest things, right? So here's the website for Space Jam, and from like 1996. And if you look at the page source, it is much more simple, right? There's only like almost all of the source code is just blank space. But here you can see very clearly like what it's trying to do, and this is easy to understand. But all the complex websites today are a little bit tougher, and so this thing does that. Okay, so we have HTML node and HTML nodes. HTML node is for a single element. Okay, HTML node, I don't know if you guys can read this right here, but it says HTML node is like double bracket selection, okay, in that it extracts exactly one element. If it's given a list of nodes, HTML node will always return a list of the same length. The length of HTML underscore nodes might be longer or shorter. Okay, so or actually, I guess. Okay, so we have that. That's that. Okay, so that's how we get the rating. So here for rating, I'm saying take the HTML that we read in, find the tag that the node's strong span, select out the text, and then turn it into a number. So rather than having that, and so now we have the rating as a numeric thing that we can now deal with. Okay, let's say we want to extract the cast list. Okay, so under the Lego Movie, here is the list of actors. Okay, and so you know, using Selector Gadget, I select I want this thing, and but I don't want this. And is there anything else? 30 things are being selected. I have a feeling I don't want. Okay, I just want the names, not the actual things here. Okay, and so here is the kind of the selection that I'm doing. .item prop apparently, whoops, will be what we use to select it. Okay, apparently when I did it last time, it gave me a different set of tags, but it should still work. And so here I'm taking the HTML object Lego underscore movie, we're piping it into HTML nodes, giving it the set of tags that we want to use, and we're saying we want the text. So if I do this, here it gives me the text for the cast. Let me see if I use the thing that I did here. Yeah, same thing. So sometimes when you use Selector Gadget, based on the order in which you click the links, it might find a different set of tags, like you and your friend might have a different set of tags that basically will return the same text. Okay, you know, as long as you verify with Selector Gadget that it's just selected the things that you do want. Okay, so here now I have a list of kind of the actors' names that appear in the movie. Okay, you can even extract. Oh, you know what? This was when I was dealing. Let me see if I can get just the picture. All right. Well, let's try this. This has two things selected, but let's see if I can extract. Okay, so here I'm going to try to extract out what I have, and I have two images. These are the. So here I'm pulling out the attribute src for the source of the image, and it gives me kind of the path of the thing. So that's, you know, if I needed to later download these or something, we could then feed these into. I don't know what this one is. Okay, so these are kind of the two images that appear in the thing there. Okay. All right, and you can extract anything, something like text of a movie. Okay, so this is a very powerful tool in of itself, using Arvest for extracting information out of a web page. Okay. You know, you can, if you want to go, you know, certain things don't play as nice. So let's say I go to Wikipedia and I want to do a list of countries by population. Top 5 countries by population, what do you think they are? China, number 1. India, number 2. US, number 3. think Brazil's number 5. He's number 4. I don't know. Let's see. Indonesia. Okay. Indonesia's number 4. All right. Brazil's number 5. Okay. So this Selector Gadget may or may not play as nicely here. Some websites don't. Let's see. Is this just going to give me the thing I want? Okay, 223, this is kind of the path. Well, anyway, I think it would work, but sometimes certain web pages don't play as nicely. One of the, let me just kind of show you something that I think is rather cool, okay? Is you can create a little automated browser inside R using RVest, okay? And so what I'm going to do is, rather than reading in the page, so here I said read HTML, I'm going to do something called HTML session, okay? And what a session does is it basically creates a browser instance where RStudio is acting as a, kind of a little robotic browser, and it's opening sessions with pages, okay, with the server, so that it can kind of go through things. Okay, so here, what I can do is I can say we're going to start a session, and this session is we're going to just call it S. Okay, so S is my session. So if I say what is S, that's what it is, and class of S is that it is a session. Okay, and what you can do is you can say, you know what, I want you to follow the link that says Will Arnett, okay? So on the Lego Movie webpage, there's a link that's Will Arnett, right? Okay, so if I told you, go to the webpage and click the link that says Will Arnett, you would find the blue text that says Will Arnett, and you would click that, and we would see, okay, Will Arnett is a Canadian-American actor, and he's known for all of this stuff, right? Okay. So I can say, what I want you to do is I want you to go S and follow the link, okay? So if I say, start with our session and follow the link that says Will Arnett, what it's going to return is it's going to follow that link and return another session, okay? But what we want is we want to actually extract the HTML from that session, okay? So we're in this current session of being in the Lego Movie page. We're going to follow the link that says Will Arnett. We end up on Will Arnett's page, and from Will Arnett's page, maybe we want to read in that HTML and extract things, okay? So I'm going to say follow the link, read in the HTML, and save. So here I'm saying start at the session, follow the link, then read in the HTML, and what you find there, save, we're going to save it as Will Page, okay? And when I do that, now I have Will Page and class of Will Page. This is, an XML document here. And so now I can take Will Page and pipe that into, HTML nodes and pull out, let's say we want to know what are the movies that Will Arnett has been in, okay? And so if I just say if I use these tags BA, okay, and we pull out the text HTML_text, okay, we can see, okay, here's a list of all of those movies that Will Arnett has been in himself, okay? So this is where I think RVest really shines through with its power, is that we can then, let's say you wanted, I don't know, you're playing 6 Degrees of the Lego Movie or something, and So you want to start at the Lego movie, and then you want to say, okay, I want to go to Will Arnett's page and see all of the movies that Will Arnett has been in. Then after going to his page, we're going to go back, and then we're going to go to the next actor, Elizabeth Banks, go to her page and see the list of movies that she has been in. And then we go to Craig Berry's page and see the list of movies that he's been in, etc., etc., etc. Okay? So what I'm going to do here is I'm going to create an empty list to kind of store all of the stuff that I'm going to do. Okay, so we're going to start off with an empty list. Okay, and then from earlier, I have kind of my cast members, right? So earlier we used, we pulled out the nodes, item prop, and I have the list of cast members, right? So here is the list of, so we're going to follow Will Arnett, Elizabeth Banks, Craig Berry, Alison Brie, etc. Okay, and so we're going to just, for this demo, I'm going to run a loop, and for each of these things, first I will start in for I in cast 1 through 3. So this is going to just go through Will Arnett, Elizabeth Banks, Craig Berry. And we're going to, for each one, we're going to create something called the actor page, which is done by starting at our current session of the Lego movie, following the link, and then reading in the HTML. Once we've read in that HTML, into our list, cast_movies, okay, into the first element of the list, we're going to create something called $movies, which from the actor page, we're going to pull out the nodes B_A, which we earlier established is the list of, right here is the list of movies that that Will Arnett has been in, okay, or each actor has been in, okay? And then perhaps I'm not satisfied with just the list of movies, but I also want to know the year that those things have been, the year that those movies were created, right? So again, you know, kind of following along on this page, using Selector Gadget, I want to pull out these years. So I'm going to click Selector Gadget. I want this year, and that actually looks to be pretty good. If I use just .year column, okay. Okay, apparently when I did it last time, I did filmography .year column, okay, and we're going to do HTML text, and then I guess I want to extract the string, the 4-digit year string here, okay. Here, what I'm doing is so for each thing, I'm taking that thing, the text, and then I'm just taking the first 10 elements. So, right, Will Arnett's page returned 230 movies. I'm going to just say, give me back the first 10 by saying head 10, okay? And then we can go through this, okay? And so here I'm going to go ahead and run this, and it's going to run it just for the first 3. And right now, my cast movies is an empty list, okay? Empty list here. But I'm going to populate it using kind of the automated browser here. So again, each thing we're following the link, and then once we've loaded up that page, we are doing a few things, such as extracting the list of movies, extracting the actor pages, extracting a bunch of stuff. So I click this, and we can see, okay, here it's going to the first link, then it does its thing, it goes to the second link, it does its thing, it goes to the third link, and it does its thing, okay? Now let's take a look at this list, cast_movies here. Okay, and this looks pretty good. We can see the structure of cast movies. Let's take a look at the structure of cast movies, and it's a list of 3, which makes sense. The first element in the list is Will Arnett, and Will Arnett itself is a list of 3 with movies, years, and name, okay? The next part of the list is Elizabeth Banks, which is a list of 3 itself, movies, years, and name, and then Craig Berry, movies, years, and name, okay? And, you know, I can unlist this thing, but this will be a huge mess if I did that. Okay, now it's just a whole bunch of stuff here. So, you know, I want to kind of present this into something that is a little bit easier. So here, looking at just the first thing, I've got kind of Will Arnett's first 10 movies, the years of those first 10 movies, and then the names here. Okay. There is something called data under library data.table. There's a little function called rbindList, which if you give it a list where all of the elements in the list are of the same structure, which is what we have here. We've got, looking at the structure of cast_movies, you know, I've got a list of 3, and each of those 3 elements of the original list is a further list of 3. I can bind those things together, okay? And now I have kind of a nice little table showing, going through the actors from the Lego movie. Will Arnett, these are his 10 movies and the years of those 10 movies. Elizabeth Banks, 10 of her movies and the years of her movies. And Craig Berry, you know, 10 movies there and the years associated with those 10 movies. Okay, and this can be, you know, all we did is we created a session and we said, you know, follow the links with this text. Okay, now you can give it all sorts of stuff under the command follow link. I think follow link makes the most sense in that you're giving it text here. Okay, but you can select with an integer or a string. Okay, so selecting a link, you can give, yeah, there's a few things you can give it, either an integer or a string. It's going to follow the first link containing that string, which is case sensitive. So it could be a slight problem if you have a whole bunch of links with the exact same name, then that could be a little bit of a problem. But you can also select it with the ith link, and you can say follow the 20th link on that page, which will be unambiguous, but perhaps a little bit more difficult to encode that way. Well, I thought this was really cool. I don't know about you guys, but so you know, here, whenever this is another thing. Whenever you're trying out an automated browser, play nice with the server. What I mean by that is don't, when you start off, don't do for I in cast, okay? Because cast, how long is cast? Okay, cast is only 15 elements. But let's say there's like, you have 100 links on that page or something. Don't just give it all 100, okay? Because, you know, what you're effectively doing is you're telling R to click that link, and then click the next link, and click the next link, right? And every time you click a link, you're basically pinging that server, and you're saying, you know, give me some information. And if you do this too much, okay, the server might think you are trying to do some kind of attack on it, okay? And they might block you or something like that, all right? And some places, like, you know, we're accustomed to visiting sites that run on these massive server farms, right? Like half the internet runs on AWS and things like that. But some people, the server is literally a desktop computer in some corner that's just connected via, you know, a cable, and that thing can't handle so many requests, and so it's not very nice to just give it 100 requests within a few seconds. So always, if you want to test something out, just say, you know, for cast in 1 through 3, 1 through 5, just give it a few requests at once to make sure it's working. You only need to follow the thing, you know, 3 or 4 times to make sure that your loop is properly functioning. And only then, after you're sure that your thing is properly functioning, and you say, okay, now I want to go after, you know, 100 links or something, then you can feed it, okay? And you can even give it a command of like a system timeout and say, you know, after you've done one iteration of the loop, wait 3 seconds before sending another request or something like that. Obviously, that's going to slow down your task, but it just tells, makes your computer play a little bit more nicely with the server and not bombarding it with like a, you know, a DDoS attack or something. So, you know, but we can do this. We can follow the first 5, and then and if we bind those things together here, we've got, you know, a pretty impressive, what I think to be a pretty impressive thing here, okay? And so that's an impressive thing with Arvest, is that you can create a session and follow things. I believe there's even a way to fill out forms in Arvest. I haven't you know, I'm not entirely sure about how the form works. Let's see. Make link to Google form, guess encoding, HTML form. So if you just kind of look at the table of contents for the Arvest package, there are a few things. I have not messed with form submission or things like that, but you can try to test it out and see if it actually works or not. But just having this, being able to create a session and follow links and then extract pages that are, you know, 1 or 2 layers beneath the front page, I think is a very nice nice feature there. Okay. Are there any questions? Yes.
What was the command to make it into a single table?
That was our bind list. Okay. Our bind list is a little bit, it's a little bit picky. Okay. Like you want to make one data table from a list of many, but you want to make sure that all of the lists that you're giving it are kind of the same form. Okay. All right. Well, anyway, I thought that was really cool. And you know, I think homework 3, I'll have you do a little bit of stuff using Arvest and try that out. Okay. So let's continue on here. So that was our Arvest demo. You have the code for it in there. Okay. The last topic for today, which I think will take a fair amount of time, is regular expressions. Have you guys used regular expressions? A few of you? Okay. At least heard of regular expressions? Maybe? There's of course, a relevant XKCD topic for regular expressions. And I don't know if you guys can see this. Well, anyway, regular expressions allow you to do really cool things, such as in here it says, you know, whenever I learn a new skill, I concoct elaborate fantasy scenarios. And it says, oh no, the killer must have followed her on vacation, but to find them we have to search through 200 megabytes of emails looking for something formatted like an address, right? And that would be terribly difficult to do without automated help, but with regular expressions allows you to do something impressive of the sort. Okay, let's take a look here. I like to use package stringer for handling regular expressions, and here is the online vignette for stringer. Okay, so install.packages stringer, library stringer. I'm going to go ahead and clear out my global environment here. Okay. And with stringer, it allows you to just kind of detect or extract strings, or things dealing with string information. Okay, and so here are some of the basic functions. We've got string underscore detect, which will kind of return true or false if it detects the presence of a pattern within a given string. So you give it a string and it's going to look for a pattern. The pattern is, we use regular expressions to define the pattern. Okay. Here are a few other functions. Well, let me just kind of list off. String locate will tell you, like, it's the pattern. I've located the pattern starting in position 15 in the string of text that you've given me. Okay. Or if you give it a pattern and it says, yes, I found this pattern in the text. Okay. String extract will extract the pattern from the text. Whereas string match will extract capture groups. So I will explain capture groups in a moment here using regular expressions, and that allows you to pull out certain things. And you got split and replace and all of these things. And then you have such as string underscore detect underscore all, which you can give it if it finds multiple occurrences of the pattern in the text. Okay, so for example, let's say the text that we are looking at is this vector of strings. Okay, the vector the quick brown fox jumps over the lazy dog. Okay, where this the has a capital T and this the is a lowercase the. We can use string detect. We're going to give it the vector of text and ask for it to search for the pattern quick. Okay, so in this case it says I did not detect this, and I did detect it here. In the second one, I did not detect it anywhere else. Okay, or we can say, see if you can detect the string O, the pattern O, in all of these different string things that we have, and it says I found it in the third, fourth, sixth, and last. Okay, and that's because we got brown, fox, over, and dog as far as detecting O. So here pattern doesn't really seem like anything. It just says, do you see, Q-U-I-C-K, or do you see O? Okay, or here, do you see R-O-W somewhere? Okay, and that only appears in the word brown. Okay, so it's just looking for this exact kind of a match within this string. So that's the simple matching here. So far, no regular expressions here. It's just basically find in a text document. With regular expressions, we have these things called meta characters. Okay, these are the meta characters, and these allow you to express certain things. And if you want to actually match a literal, like if you want to match the actual square bracket itself, you need to escape that meta character by giving it a backslash. Okay, unfortunately, the backslash itself is a meta character, so you have to further escape that. So if we want to match this literal square bracket, we have to do double backslash square bracket here. Okay, so here we're saying, if you did it this way and you say, do you detect the square bracket in here, A, B, C, D, square bracket D, E, F, and you say, do you detect the square bracket? It's going to give you an error. It's going to say, when it sees a square bracket, it's thinking it's going to have some kind of range, and it doesn't see that. So here you have to say, I want the literal square bracket by doing a double backslash escape in front of it here. It says, yes, I do see that character. That's right there. Okay, so these are kind of the list of meta characters that you have. We'll get to use them. So maybe perhaps I will go ahead and skip to the cheat sheet. Okay, go ahead and pull up the regular expression cheat sheet here, okay, and then we'll go back and work through these meta characters and what they do. Okay, so the regular expression cheat sheet, and what is this? Okay, this will match certain things here. Okay, so we've got you know, anchors and things of that nature. Okay, so an anchor is, you know, look for this pattern only if it's at this kind of location, okay? Either at the start of the string or the end of a string or at a word boundary, okay? A word boundary is, you know, if you've got, you know, a paragraph of text, basically word boundaries are spaces indicating that this word began here or ended here, or, you know, if it has punctuation, it will recognize that as a word boundary, okay? So using the caret or slash capital A is for the start of a string, or $ or slash Z is for the end of a string, and then slash. A lot of times, the lowercase is for the thing, and then the uppercase is the complement of the thing. So slash little b is the word boundary, and slash capital B is a not a word boundary. Okay. All right. So here, if we give it the text, which is the full thing, the quick brown fox jumps over the lazy dog, okay, and we say replace within this string text, replace if you match the pattern caret the, okay, and so this means only match if it's at the beginning of the text, okay, and indeed the word the is at the beginning of the text, so we have a successful replacement of the word the with the dash. Okay. Over here, I have capital THE $. This means only do the replacement if you find the word the, but it has to be at the end of the string. Okay. And looking at this, there's no capital THE at the end of the string, so no replacement has been done. Okay. With here, I'm saying replace the word dog if the dog appears at the start of the string, which it does not, so there's no replacement. Okay, but here we say replace word dog if the dog ends the string, and it does. Okay, this stuff is sensitive to white space and all of that. So let me just kind of show you. If I have this and I do that works. This also works, but if I put in a space here, there's no match, right? The text here, dog space $, this is not a match to what we have, okay? This is. Or if my text string has a space there, okay? If the text, there's a dog space to end it, and I ask replace it with this, it finds no match, right? But then if I put a space here, then it will match because this is what we have. So it is sensitive to white space. Okay, here we have you can use the /A, or in this case the /A, to indicate the start or end of the text. Okay. So these, you know, /A is the same thing as using caret, and /Z is the same thing as using the $, to indicate the end of the text. Okay, and here /B and /B means you are going to look for the word boundary then jumps, and then a word boundary. Okay, so here it matches the word jumps, but if I say //b jump //b, it does not match, because while it does match this part, word boundary jump, because of the S here, it does not match. Okay, if I oops, yeah, let me fix this. This is what I have. Okay, if I get rid of this //b right here, okay, so look at line 181, and if I get rid of this, will it match and replace, or will it not do anything? What do you think? What will it return? Yeah, it will give me a dash and leave the S. So it'll say the quick brown fox dash S over the lazy dog, okay? So it does match because we do have a word boundary up in the front, and it just matches the JUMP, but it doesn't care about the end here, okay? But as soon as I say it has to end with a word boundary, it finds no match and returns the original text, okay? Here, if I say not a word boundary, capital B, UMP, capital B, this will say it finds no match here, okay? And over here, it also finds no match. This is also no match because this is what we have. But, capital B / capital B is not a word boundary, meaning it is not at the beginning of the word or at the end of the word.
So line 182 does match.
So line 182 does match because UMP is not at the word boundary, okay? All right, I modified 183 a little bit. So it says word boundary, JUMP, non-word boundary, capital B, right? Non-word boundary. Will this match? Will we get a replacement here or not? It will, okay? Okay, because jump is at a word boundary, and the end of jump is not at a word boundary. So it will match, okay? If this all seems like gibberish and strange to you, if you play with it and you see like, will this work, will this not work, that will help you understand, okay? All of these things I recognize, you know, the first time you're looking at it is not a whole lot. Okay, we can specify character classes. Okay, little /s is white space, both breaking and non-breaking spaces, and capital S is non-white space. Okay, so anything that's not a bunch of returns or something like that. Little d is for a digit, capital D is non-digit, little w, is a word, and capital W is non-word, okay? So this will match word being letters, alphanumeric, okay, but not punctuation and symbols, with the exception of the underscore. So I guess, yeah. So these are word, characters, and non-words. So if you escape any of these things, this will give you character classes here. You can give it also specify ranges of character classes, okay? The dot is any character. This is gonna match everything, and maybe that's what you want to do, but it's also like it matches everything, okay? Here is a range. We're saying we want the letter A, B, or C, okay? You put in a caret inside the square bracket, and it will say anything but those letters, okay? You can also give it a range using a dash and say, I want the letters A through Q, or here I want the uppercase letters A through Q, or the digits 0 through 7, okay? So let me just kind of demonstrate some of these things here. So let's do I'm going to do string replace JP. Okay, what happens with string replace? It replaces anything that has a J or a P, but in this case only the first one. If I want to replace all of them, I do string replace all, and it will replace the J and the P. Okay, these are individual. Okay, here I can do capital T and O. Okay, and so this replaces capital T, the O here, and things like that. Okay, it does not treat this as the word to, or if I do THE inside the square bracket, it will replace capital THE and then the HE over here and then the E over here. Okay, because it sees these as individual letters. Okay, and that's because I've done string replace all, which means replace all matches of THE here. This is the same as doing this. Okay, it doesn't. These are going to return the same thing because the order of the letters in here don't matter. It's not looking at it as a word, but it's looking at it as a list of characters that we're trying to match. Okay, and if I do do this, it's going to give me back everything else, right? It's replaced everything that doesn't match that with this. Okay, so and of course string, if I get rid of the underscore all, it's going to just do the first instance that it matches of HTE. Okay, does this kind of make sense? What's going on here with these classes? Here, I'll just show you what some of this other stuff is. Okay, we'll do /s for the white space, and let me do string replace all. Okay, so it replaced all of the white space here. If I say, whoops, non-white space, okay, it preserves the white space, and it replaces everything else with dashes. Okay. What else do I have? Digits and non-digits. I don't have any digits here, but this replaces all the word characters. This is all of the non-word characters, which in this case is just the white space there. All right, here we have quantifiers. Quantifiers will say you must match this many. Okay. So match 0 or more with a star, match 1 or more, match exactly 0 or 1. So let me just kind of demonstrate. Let's say we have bracket capital THE. Okay, so here it's replacing every time it finds any of the letters T, H, or E. If I put in a plus, it will do it replaces 1 or more, okay, with the dash. Okay, so suddenly TH and E here in the original text, this matches together as 1. Okay, and again the order inside this bracket doesn't matter. So whereas when I had without the plus, it saw each of these as individual matches and replaced each one of them with a dash. When I put in the plus, it says 1 or more match those, and so it replaced all THE with a single dash, and here the HE with a single dash. Okay. Star is something. What did I do here? Oh, 0 or more. 0 or more. Okay. Star is match 0 or more. So it found no match between the Q and the U, and so it replaced the no match the 0 with a dash. Okay. Okay. The question mark matches exactly 0 or 1. Oops. So every time it didn't find something, it does that. Okay. Here, if with a curly brace you specify an exact number, so here it will only replace if it finds a match with exactly 3. Here it will do a replacement where it finds a match of exactly 2, which it did here. It matched the capital T and the H, and over here the H and the E over here. And I can do 2 through 3. Oops. Oh, I guess 2 comma 3, 2 or 3, and it will match match those. So this tells the thing, you know, how many of these to match. Again, the best way to learn all of this, play around with it. Okay, play around with it. Sometimes, you know, especially when you use the dot for any character, okay, which is going to match any character here, you can run into this problem of greedy versus ungreedy matching. Okay, so what is greedy versus ungreedy? Greedy matching tries to match as much as it possibly can. Okay, so here I want to say I want to extract the match div dot star div. Okay, and here it's going to try to like find the first and the last matching of this. Oops. Of this thing here, okay? And so this is the match. So this is the text. The text is this, okay? And I want to extract where it starts with these exact things, the tag div and the closing tag div, opening closing tag div, okay? Notice in the original text, this is the first, it's going to start here, and then it can end here, or it can end here. Okay, we have two things that qualify for what matches for the closing portion here. Okay, if I use dot star, it's going to match everything in between, and so it pulls out the exact match here. And it goes for the second closing div tag. Okay, that's the greedy matching. The ungreedy matching, I put in a question mark after basically a quantifier, such as the star or the plus, and it will say, don't go for everything there, okay? And so here it's going to just go for what's inside, and it goes with the first kind of closing thing here. Let me just kind of further demonstrate. If let me just do this character, the greater than sign and the less than sign. Okay, with extract, the greedy matching. Okay, again, take a look at the original text here. Let me kind of clear this out. This is the original text. What is this going to go with? If I do this, it's going to be greedy, and it gets everything from this. This is the first character it matches, and then goes all the way to this last one right here. Okay, so it gets all of this. Okay. Here with the ungreedy, it kind of finds the smallest case right here, which is going to be right there, and that's what it's pulling out. Okay. I think if I did string extract all, here it will find a bunch of these things. It says, okay, here's one right here, here's a small one right here, here's a small one right here, and it finds all of these in the original text. Whereas with the greedy pattern, if I did string extract all, it just finds, it's as greedy as it can be, and it just pulls out one. Okay. So that's what we have. Whereas if I did not use the all versions of these, it's going to just pull out the kind of the first thing it finds there. And that's using the question mark to go from greedy versus ungreedy. We can group together parts in our regular expression, okay? And so here you give it a pattern inside some parentheses. And this is a what we call a capture group, okay? So string extract pulls out, basically it matches the entire pattern and it returns the entire pattern. String match will go for the pattern, the entire pattern, and then it will return just the capture group. Okay, so let's say I have this is my text here. Okay, the same kind of this div tag text, and instead of string extract, I'm going to do string match. Okay. And what I'm doing is I'm going to put the capture group will be dot star inside. Oh, do I want? I'm not sure if I want the question mark inside the parentheses or outside of it. Okay, we're going to do string match all, and this is going to pull out the matching capture group from this thing. Okay, so let's see what it returns. Okay, so I want to put, sorry, I want to put the question mark in here to make it go. Okay, so here, so recall. Let me. Okay, here's my text. String extract all using my ungreedy returns this. With the capture group, it goes through each of those things and it returns, because I have this part inside the capture group, it returns the part that is between the these tags that I'm going for. If that makes sense. Okay. Or, you know, perhaps I just want to get, I want the actual tags itself. Okay, so we'll do a string extract all. Let's say I go for this. Oops. Okay, so these are basically the tags that I'm going for. And if I put this inside the match, this will pull out the inner contents of those tags. Okay, and perhaps I don't want the closing slash, and I can say, you know what, I want the slash, but I want it to be optional. Oops. 0 or 1, we'll do that. Okay, and so now I can pull out just this, and it doesn't have, I don't know, the closing slashes or something. So you can pull out stuff of interest using capture groups. Okay, so capture groups specify text within the pattern that is of interest to you. So perhaps the entire pattern that matches is this entire thing, but if you don't want that entire thing, you can just put parentheses around the capture group that is of interest to you. Okay, and you can specify multiple capture groups. Okay, so here this will say match the entire string A, B, C, D, E, F, G, H, I, but the capture groups that we want are A, B, C, and G, H, I. Okay, and these are full strings because the square bracket is a class and says, you know, any of these things, but this will be the entire pattern G, H, and I. So here, just a few examples, A, B, C, D, E, F, G, H, I. Match the pattern, okay? Extract will match the pull out the entire pattern that matches. Match pulls out the entire pattern that matches, and then in a separate part, just the capture group of interest. If you have multiple capture groups listed, it lists those separately. So the first will be the entire string that matches, and then just the capture groups. Okay. You can reference capture groups Okay, so here I have this. If I do string replace, shoot, what am I trying to? Now I'm. Let me think of an example here. You can replace text using some of your capture groups as well. Although I can't think of a good example off the top of my head, but if I use the use //1, it will use this as it will refer to this portion of text, the capture group. And if I use //2, it will use this portion of the capture group. So so here it's replacing it. It matches the entire pattern here, and let's see. Maybe I can say we matched, or we, yeah, matched capture groups //1 and //2. Okay, but although that's actually not what I want to do. But you can reference in the regular expression the results of the capture group itself as well. Okay, here's an example with a bunch of stuff. Okay, here is text with Apple and then some digits that look kind of like phone numbers. And here we're going to say this is a regular expression that looks like a phone number. Basically, your area code has to start with a digit 2 through 9. No area codes start with a 0 or 1. And so we say, give it the digits 2 through 9 as the first digit that must match. Then the second thing can be any digit 0 through 9, and we want 2 of those, right? So this is a 3-digit thing, and this is the first capture group. The first capture group here is basically our area code. Then we have a class of either a dash, a space, or actually anything will allow it. And then the digits 0 through 9, we want 3 of those. Then something that looks like a dash or something, and then digits 0 through 9, and we want 4 of those. And we say, go through this text and extract anything that matches the phone pattern. Here it says we found no match, and here it finds the kind of the first 2 phone numbers that matches there. Okay, and in this case where there were 2 things, it only pulled out the first one. Okay, if I did extract all, okay, what it returns is a list, and it says under the first thing we found nothing, under the second thing we found this as a match, under the third thing you gave us, I'm sorry, under the third thing we found this as a match, and under the fourth thing you gave us, we found 2 matches that we were able to extract, two instances of the pattern that we were able to extract. Okay, using match, which takes into account the capture groups as defined by the parentheses, okay, we now have things being pulled out, okay? The area code, the prefix, and the last 4. Okay, so that's what we have there. And then match underscore all. So here, with match, it only does the first instance of the pattern. With match underscore all, it will do all instances of the pattern that are found. Okay, and so in the first case, it returns an empty. Second, here's the entire pattern that matches. And then in the fourth case, where we have both the work and the home listed, it matches both of those and extracts matches the capture groups listed there using the parentheses. Okay, so yeah, regular expressions, really powerful stuff. The best way is to just kind of mess around with it. There's this nice little applet on the web that allows you to kind of test regular expressions. Here you just use a single slash, not R's double slash to escape characters. Okay, so what is this? This is saying, you know, anything with a capital A through Z. Okay, this goes into the capture group. Okay, this is any word character, and we want one or more of those. Okay, and well, slash G, don't worry about that. Okay, and so here you can kind of see the matches that it gets. It says 21 matches, and because only the capture group is in parentheses, if you hover over it, okay, it will say what did it match, as in the entire thing, the entire pattern. The entire pattern that matched is community. What is in the capture group? It's just the capital C there. Okay, over here. The entire pattern that matched was the word reference, and what the capture group is the capital R here. Over here, the entire match is this, and the capture group is that. Okay, so basically this says, this pattern is for anything that starts with a capital letter. And then here, you know, you can just kind of test out different things. If I get rid of the plus, then it's any set of two characters where the first one is a capital letter. So here we have W-E, R-E, capital E-X, and so on and so forth. Okay, the plus makes it to be one or more. The star is 0 or more. So, you know, over here, if I just put in the capital A, B, and D, and if I put in a star plus here, these will not match, but if I put in a star, they will, because star is 0 or more, okay? Meaning that the other word characters other than the capital letter here are optional. If I put star star, then it says infinite. It matches 0 characters and therefore matches an infinite number here. If I put this in a plus here, this changes what it matches. So here, this capital A through Z all get put in the group, whereas without that plus there, only the A ends up in the group. So this thing is, I think, very, very good. And you can kind of just test out stuff. You can paste in extra text, you know, if you want to find things there. Okay, that's today's lecture. I will post up homework 3, and then I'll post up a little bit of information. I guess I'll just talk briefly about the midterm exam. The midterm exam is mostly going to be, I'm going to have some code written down, probably not the most elegant or most beautiful code, but you're going to have to go through and I'll say, you know, based on the code written here, what will it produce, okay? I will probably put in a few tricky cases of, you know, here's a function where, you know, I'm changing the values of things. Does it affect things in the global environment or not? and things of that nature. I would say study the examples and the lecture notes. You know, mess around with some of those things. Make sure you have a good understanding of the stuff. Today's lecture, so RVEST and regular expressions, those things will not be in the midterm exam, okay? But basically up through last week. So everything from first week and second week is fair game for the midterm. And it's mostly going to be me with giving you some code and asking what will R return or something like that. Okay. All right. Good luck.